Okay, good afternoon, everybody. So I would like to welcome everybody in my course. This is CS4306, right? You are in section 2, right? Okay, so this course title is Algorithm Analysis. And so this is our course location and other information. So we will meet every Tuesday and Thursday, right? This time 2 to 3:15. Okay, and this is the course syllabus. I added this in D12. So everybody does have access to D12, right? Yeah. Okay. By the way, I am recording the entire session. Okay, I will mostly use digital, not blackboard, whiteboard. Okay, I have digital board that I will use, so that, and I will be recording, and I have my YouTube channel. I would like to post the entire recorded video in my channel, so that in case you are absent in this course, in a lecture, then you can come in and you can watch the video. And sometime due to bad weather or something, your busy schedule, if you cannot join in, you cannot come in here, you can join in from home or anywhere. Okay, but I like everybody, please do not miss any lecture. The rare case that you miss, that you make it up, okay, at your earliest convenient time, especially before the next lecture you complete it. Okay, but since I will be recording the lectures and then I will put in a public YouTube channel, I don't have personally my hesitation about privacy issue, but if anyone has any privacy concern that your voice may be coming here, okay, that may, if you feel as a concern, please let me know. Okay, or in that case you do not speak. Okay. Has anyone any concern about your voice recording or privacy issue? Okay, so if you have, then please let me know. Okay, please email me. Otherwise I will consider that you are okay with this recording. Okay, so everybody has access to D12, right? So if you go to D12, you see that so go to course content. So you see the syllabus over here, and the book Introduction to Algorithm. This book is an older edition. I added it in here in D12. That is for free. You can have this PDF file. I will sometime use this one. Okay, but I will come up soon that if you want to, I would like to have open book test. I don't like to give you hard time to memorize some very large formula and technique. Rather, you know the technique. Okay, see your note. You can have your cheat note, as many pages as you want. But in the test, you will not be allowed to open any what's called digital resource. Are you okay? I can do two ways. I can test to you closed book or open book. Okay, if it is closed book, then everything is closed. But if it is open book, then not everything open. Every printed material or your handwritten material is open, not an electronic device. Okay, so did you have a chance to look at the announcement, first announcement, everybody? So this is my name and my office hour, that building, not this building. I used to sit over here, but I'm moving to next building, Norton Hall. Okay, and this is the announcement. It's very simple that I asked you to do two things. First of all, if you have not done yet, please download the course syllabus. Okay, download the course syllabus from D2L. Here, course syllabus from D2L, and read it at least one time. Okay, I will have a quiz to be due next week to check whether you have read the syllabus and my special communication policy. Okay, so if you go to my syllabus, it is maybe 10 pages. Okay, you don't need to memorize it. Okay, so if you're a fast reader, then you can read it within 20 minutes, that's fine. Okay, first of all, my communication policy, the KSU communication policy is that please do not send an email from your Gmail or Yahoo mail or your work mail. Okay, work email from any other email. You must send me email from your KSU email, nothing else. Okay, from your KSU you have something like your net id at students.knesa.edu, right? Send me email from that email address only. If you send me an email from any other email address, I will not reply to your email. When you get an email, if it is external, if it is not KSU, it shows us that it's external. By looking at subject line, we see that this is not from KSU. I will not reply to you. Okay, every semester I tell this, but since still many students they do mistake and they blame me that our professor does not reply to me. The problem another problem is that do not send me email from D2L. You see that D2L has an option here, send message, right? So if you can here email, you can say mail over here from D2L. If you send me email from D2L, it will come to me, but if I reply to you, it will not go to you. For many students, they send me email from D2L, I quickly reply, and then it bounced. If it is bounced, then this is double headache for me to find out your email address and then forward that email address to me. So please do not send me email from D2L and from your non-KSU email address. I will create a Microsoft Teams team or group. Okay, for short communication, you can send me message from there. I will do that after the ad remove period, maybe by the weekend. Okay. Yes, you have a question? You have a question? Yes.
On the open notes, so you said it's like open textbook but closed notes for the exam?
Open textbook, open your printed material, your hand note, whatever you like, but not an electronic device.
Okay.
You understand?
Wasn't the textbook online, or did you print out the textbook?
Yeah, you can print out textbook or better buy one. So this is the algorithm book you will need for your whole life. If you want to be a software engineer, or if you want to stay in computer science or software engineering major, you will need this book. Still, I have this book and I read sometimes this book. This book is a very large book. We will not cover everything. But if you do masters or PhD in computer science, you will need to get same book again. Okay, so I like you to collect this book, hard copy. Buy this book. It is worthy. Okay, if you can buy a used copy, or you can buy new copy, whatever you said. But for the test, you must have a printed material. You understand? For now, you can use PDF copy, right? So for instance, I added this one. You can download in one click, right? You can download it, but we can use it. But in the test, so you understand my test policy. If you don't like this, then I can go close book. Okay, what do you like? Now, if it's closed book, then questions will be easier, a little bit easier, right? and then it is open book, that question will be something you need to use your brain. Okay. So this is the course actually where you will learn how to develop your own algorithm and how to justify whether your algorithm is good or bad, efficient, right? So for instance, now if I want to drive from here to downtown, okay, so this we can see the solution is an algorithm, right? Get a bus or train or a taxi or your personal car and then drive through, then go to downtown, right? So how many routes are there to go to downtown? How many? Huh? Okay, then definitely more than one. So now, so how many? Can you guess? How many? At least 3 or 300 or maybe 3,000, right? If you wish, you can go to from here to go to California, then come back to another route and then come downtown, right? The easiest way, maybe the shortest way will be through I-75, right? If someone likes or someone needs, then he can go to Florida and then come back through Savannah and then other way, right? So then you will assess which one is efficient, which one is worthy, right? Which route is worthy for you, right? So if you have a relative to pick him up from Savannah or from Florida, then you should go there, right? And you should go there first and pick him up and then come to downtown. So that one will be your efficient way, one worthy, right? Even it is costly, time consuming, that will be helpful. But if you need to go quickly, then maybe 75. If you get a grant money or someone give you pleasure tip that okay, as much money you want to spend to go to from here to downtown, I would go to California first and Hollywood and then other places. I would have a trip over there, all over the America. Then at the last point I would go to downtown, right? So it depends on the situation. So then we will learn which situation is better for us or which one is the best. If we cannot find the best one, in case we cannot find the best algorithm, we will look for a better one. A better one, more better, right? So for instance, there are some known algorithms, like for instance, sorting algorithms, right? You have some numbers, you want to sort them either in ascending order, maybe from the smallest number first, then the greater number, okay? So this is a known process, right? We know this from our early childhood, but still a lot of research are going on how to develop more efficient, more better and less time consuming sorting algorithm. Still it is the research going on, right? So in this course just you will learn how to develop your own algorithm, and then you will know how to justify your algorithm, whether it is good or bad. So then how do we learn algorithm to develop our own algorithm? Actually we will learn first by learning from other existing algorithms, right? We will learn what are the existing algorithms that other people have developed or people are using, and then based on those existing algorithms we will develop our new algorithm. Okay, we will see that one was something time consuming, my algorithm is something better, right? So at least if we cannot say better, we will say pretty equal, okay? But we will give a try, even we cannot, okay? So I like to have in the test, during the test I like to have you to get webcam. the test. I think you will have your laptop, right? Everybody will have laptop, right? Has a laptop, right? Everybody has laptop, right? So in the test, so please be prepared to take your laptop with the webcam before your test. So in the schedule page, so these are the learning outcomes. So please go through these slides. Okay, and okay, this is my grading policy, and this is my replacement grading policy. Okay, if you miss test, there are two tests, test 1 and test 2. If you miss either test 1 or test 2, okay, or both, there is no reschedule to take it, but your missing test will be compensated by 80% of your final exam grade. That means with 20% penalty, right? That means if you in final you achieve 20 out of 20, so then you will lose 4 points, right? And then you will get 60 for your missing test. Okay, but if you miss the final exam, then you will get 25% penalty from your test 1 and test 2. Okay, so there is no makeup for quizzes, but for the assignments, some of the assignment I will give you assignment due date and extended due date. Okay, if for instance the assignment due date is a weekend, will be on the weekend, okay, and the next 2 days will be extended due dates. So during extended period, for each day or part of a day, you will lose 10% of point, total point, okay, for that assignment. Okay, so and after the extended period, there is no acceptance. Okay, I think these are the important thing you need to know. So remember, okay, I will give a quiz based on the syllabus and my communication policy. Okay, I'm very strict about my communication policy. I have many students. If I may know you by name, by the end of the semester I will know many of your name. Okay, but if you do not tell me your section, it is difficult for me to find out which section are you in, right? But it's easy for me if you tell me your section, that professor, I'm in this section, yes, for 4306 section 2 S2, then I remember quickly, right? I can give you quick reply. Okay, so I have a YouTube channel. I will put my lecture, even including this lecture video, over there. 80% cases I will be successfully able to save the video, but sometime I may not record it may not be saved. So in case I have another section I will be teaching in the evening, I can share that video with you. Okay, so whichever is better I will share with you. Okay, and then this is the tentative course schedule. So this is not fixed. Tentative means it is not finalized. Okay, but this is pretty finalized. There will be some, due to some circumstances, there will be some changes in the due dates. Okay, hopefully you see that for every quizzes and test I have 1 week blank. Okay, so in case I cannot cover this, I will move this to the next week. So all over the semester I will try to optimize it. Okay, but sometime, okay, if I make any change in the syllabus, maybe if I find it a typo or something mistake, I need to change any statement, or even if I move any due dates. So what I used to do, I usually change my syllabus with version. You see that version 1.0, I may say 2.0 next time, or 1.1 something. Okay, especially maybe that there will be changes in the schedule, not in the syllabus. So last semester what did I do? I changed this 6-7 times. Sometimes I got some typos and changed that, and every time I change it I update it with the new version. So some student blame me, the professor, he changed the syllabus 6 times. I did not change the syllabus 6 times. Maybe 4 or 5 times I changed the schedule deadline. Okay, so this time maybe I will not, if there is a change over here, I will put this in a new tab over here, course schedule. I will make another tab over here. Okay, so that's from my side. Has anyone any other question? Yes.
Are you using C++ or Java? Because you mentioned both of them.
For this course, we can use both, either C++ or Java. Okay.
Thank you.
Did I mention that? Okay. So everybody took data structure course, right? So this course, actually 1/3 of this course will be review of data structure. You see that 1/3 of this course will be a review of some sorting algorithms and data structures. Actually, at least 25%. So this course will be a great investment for you, really. If you give attention to this course, you will have a good foundation in programming and problem solving, right? So you did 1321. How many of you are in my 1321 and 1322 courses? You, I see. 21. Okay, so you passed 1321, then 1322, and then data structure course, right? And this is another course. So there are a few more courses. So these are the courses that if you take database course, and then programming side, you are almost completed. Then you have networking courses, other courses, right? Other side. Then you should have a good foundation now. And for this course, teaching this course is seems to me a little bit easier than teaching data structure, because you are mature right now. You know data structure. You know how to write code and how to compile it and how to fix errors, right? Okay. So now let us try together. Okay, in this journey I would like to go with you. It is not that I will run fast and then but all of you will be behind. That is not my goal. Let us go together. It's marathon race. Okay, semester 9, let us go together. If we get stuck something, please let me know. We will cover, we will review that. Okay, so since I am implementing open book test, I like you to understand but not to memorize. Okay, you understand the concept, you know the concept. Okay, so if you go to work, then you will be available, you will be open to do Google search, right? Google search and something, and you get help from other places. You don't need to memorize the entire thing. Okay, so let's go to the book. I taught these courses previous semester, spring semester, so I have a here YouTube channel, this one, spring 21. But this semester I will try my best to make more better video and then content more easier, maybe understandable. Okay. So now, has anyone any question or any suggestion? So today we are not going to cover many things, just we will see a few things last. Where's the book? Okay. So this is the book. You see there, more than 1300 pages. We will cover only a few hundred pages. Okay, not all. Not all. So let's see the syllabus. Okay, so let's go to chapter 1. So analysis and basics of algorithms. So from 13, 21 and 22, you remember that what are the ingredients of an algorithm? What are the elements of an algorithm? The two elements of an algorithm, right? Some data and some instructions, right? Some meaningful instructions. Instructions are applied to the data. Okay, so instructions need to be applied in a sequential manner and appropriately. Okay, so I will be using, so every course for KSU, for every course there is a coordinator. Okay, for that we follow the coordinators mainly slides, or they develop, or we share our slides. If I develop some slide, I share with other professor develop our slide and then share with us. Okay. Okay, so these are PDF files, so I could not change this. Actually fall 2021, it should be, the section name is different. Okay, so that is from another professor, Dr. Lees. Okay, so I will be switching from book and then slides. Okay, sometime, and then your test questions will be from book and also in slides, and quiz questions will be slides and sometime from mainly slides and book. Your quizzes will be open book. Okay, you will get about a week to complete a quiz. Okay, I will tell you all of the quizzes will be simple except the quiz for data structures. data structure course, because data structure you took in previous semester, right? So that will be covered in depth over here again. So that quiz will be made a little bit challenging. Other than that, maybe quiz 2 will be a little bit challenging. Okay, and other than other quizzes will be simple. If you go through the slides and book, read the book, then you will be able to do it. Okay. Okay. So we know that what is an algorithm, right? An algorithm is a systematic process to solve a problem, right? An algorithm has two main ingredients, some data and some instructions. Data usually are used as a raw data or input first time, right? And then finally we apply some instructions on our input data and we get a processed result. That is our output, right? So that how efficient the processing steps are, how efficient, that is the actually efficiency of algorithm. Okay, so in order to find and measure the efficiency of algorithm, there are some techniques we will learn. Okay, and how do we say that whether an algorithm is efficient or not? Just we analyze the algorithm. How do we analyze? First of all, visually, then doing some calculation, mathematical calculation, and then we will come up with a decision whether it is a good or not, right? In real life, when we do compare two things, sometimes we compare something by their weight, which one is heavy, which one is light, right? Which one is costly, which one is cheaper, right? Which one is time consuming, which one is less time consuming, which one is more time consuming, right? Similarly, in algorithm analysis, we will mainly focus on analyzing algorithm based on how much time it takes to complete the process, to solve the problem. Okay. So, in an algorithm, we know that if we can use or arrange the data in a good manner or good structure, then it is more likely that we are half done of efficient algorithm, right? First of all, we need to organize our data, then we need to apply instructions. In combination of organized data and appropriate instructions, we get good or efficient algorithm. So you know that how data are structured or organized in a database, in computer system, right? We can put data scattered way. If you have 100 books, you can at your home you can put anywhere. It's one book here, another book there, another book there, another book there. The problem might be if you want to organize the books, then you need to look or you want to find a book, a specific book. You may not get it quickly, right? You may need to search all of the books one by one. If they have some same outlooking, then this is more difficult, right? Okay. But if they are organized well, then it's easy to get them, right? So similarly in computer program, if you organize your data with good structure, good format, good arrangement, then your program will be better and then program will be faster. So we know that the first way to organize the data is an array, right? By the name of array we say static array, the fixed length array, right? The static array has a limitation. Its size needs to be fixed. But later if you have more data, you cannot put them, right? But if you have less data, If you declare a large array size, you may have possibility of misuse memory space. So in order to resolve that issue, that we need to think about other data structure like dynamic array list, right? And then there are other data structure like linked list, stack, queue, hash table. So these are just different way to organize our data. In some algorithm, it's easy to use a linked list. In some another process, it's easy to use a stack. In some process, it's easy to use a queue, right? So we know that when we wash our plates at home, and then we put one above another, right? And the last plate we wash clean, we use that first usually, right? We can use the last one, the bottom one, but that may be difficult. You can break your plates. So this way people use the top one first. But if you are waiting for a ticket or to get in a bus, we need to make a queue, right? Line as queue, right? So if the line would go to the reverse order, that whoever coming is the last one, he or she is getting to the bus first, that would be chaos, right? So we use a different order. Whoever comes first, get first. So based on situation, we use different data structures. We organize data differently, right? So we will know that which one is efficient for us, and then we use the efficient manner. So a program works better I said that in a combination of data structures and algorithm. If your data are structured in a good manner or arranged in a good way, then you're half done. Your algorithm is look likely that it will be halfway efficient. And then the next part will be algorithm. If your algorithm is good, okay, then so for instance here is an example here. So these are the data 80, 70, 90, 30. These are the data. This may be scores, student scores, right? Test scores. Okay, and if you want to sort this, maybe in ascending or descending order, right? Whoever got the highest score. Okay, so then this is the some process for sorting process. Part of the process is not completed yet. So we do like this way. So here we see that there are 4 data elements, but you said dot sign there. That means there is other hidden elements. So we can say in general say n. The number how many data elements over here. In general we say n elements. So n it start from, for instance, I equal to 1 to n. By the way, declaring array is something different in algorithms and in actual code. In actual code, we know that in array index start with 0, right? Actually, most of the programming languages. But in algorithm, index start with 1. Most of even the old books have index with starting 1. So if you start from 1, then you will go 1 to n. But if you start from 0, then you will say 1 to n minus 0 to n minus 1, right? Okay. And see, this is only one for loop. For now it has only one for loop, and I have if within this for loop. Okay, so no matter how many if conditions are here, if, else if, else if, else if, else if, so but we know that each of the statements are compared one time, right, and executed one time, and then how many, as many number of data I have, n number of data over here, so the loop will be repeating that many numbers. So by looking this code, we say that the efficiency of his algorithm is n, big O N, we say n. That means for in the worst case, you need to look for all of the numbers. So how do we remember that? This is the one way that how many looping statement we do have. Okay. So only one looping statement, so we say big one. I'm coming from this thing. Yeah, okay. So I went through this algorithm. An algorithm has some data, some input and output, and step-by-step process. Okay, so now coming this here. Coming to this code. So if I have and some code like this, I have some code like this. Okay. Then how many for loop over here? Only one for loop, right? Okay, so if you say that it starts with 0, if it's 0, then less than n. And then if you start with 1, then less or equal 1 n. So here we have 5 internal statements. Okay. Actually, whenever we analyze an algorithm, we ignore the number of internal statements. We don't care. We mainly care the how many loops, how many times the loop rotates, So here we have 5 simple statements. Let us consider that each statement takes 1 millisecond or 1 microsecond time to execute, right? So, and let us say that n equal to 10. Okay, so if n equal to 10, and then if each of these takes 1 millisecond, then how many milliseconds it will take? 10 times 5, right? 50 milliseconds, right? Total it will be 50 milliseconds. Okay, so since this number is fixed, if n becomes larger and larger, right, then you see that this value, this 5, will be ignorable, right? In that case, we say that is, instead of 5 times n, we say n, just n times. You know that whenever you add infinity with another infinity, what is the result? Infinity plus infinity. Infinity means very large number, right? What is the result? Whenever you add a large number with another large number, what is the result?
Large number.
Only one large number, right? Whenever you multiply a large number with another large number, then we say that large number squared to the power squared, right? So let us consider that only for, so then if we add 10 infinite numbers, how many, what will be the result? One infinite number, right? So same thing here. So no matter whenever we say your, for instance, here we will say instead of 5n, we say only n, because we will consider for algorithm analyzing, we will think about very large n, very large n. Okay, now come back to these statements here. So even I have only one simple statement over here, right? And then I have a for loop j equal to 0 to n, and then this is inner for loop and this is outer for loop. So then how many times the inner for loop will execute? How many times this for loop will execute? Can anyone please tell me? Huh? No. Think about one more time. Or maybe let me make it simple. How many times this statement will be executed? Think about a little bit deeper. Okay, let us make it simple. So how many times this will be executed? N times, right? It's simple, right? Then how many times this will be executed, the outer one? 0 to n times, right? And then how many times this one will be executed? Okay. This one will be executed n times, but the internally total will be executed. So that means this statement will be executed n times for this and n times for this. So these are internal looping. Okay. Then total execution will be n squared times. This is an exponential equation, right? So in case a small n, it is not a factor. But in case a larger n, for instance, n equal to 1,000, million, billion, trillion, okay, this will be huge number, very large number, right? So here what we will consider, if there is two for loops, one within another for loop, this is called inner, this is called outer, then we will say that this execution time will take n times. So here, how do we use it? We say time is a function of n. N is the number of elements equal to, so this one will take, so the total, now let us see. Okay, if I make it smaller. Now if it is my entire program, the whole thing, this one, this part and the last part. For instance, the last part we have like this. For instance, if I have 25 statements over here, right? So then how many times, how many milliseconds it will take? Only 25 milliseconds, right? If each of the instructions take 1 millisecond. So this 25 is the fixed number, right? And then how many times it will be executed? 5 times n. Okay, what about my n? And then each take 5. There are 5. And then 5 times n. And then how many times this one will be needed? N squared, right? Why it is n squared? Because I have only one statement, and then it has outer loop, so n squared. Okay, so total how much time would it take? This is n squared plus 5n plus 25. So here 25 is a constant fixed number, right? So in case this is a smaller n, for instance, if n equal to 2, right? So the what will be, which one is the dominant factor over here? If n equal to 2. So then if n equal to 2, only two data items, which one is dominant? This one, or this one? This part. Which part will take more time?
25 individual.
Yes, it will take, this part will take more time, right? and this part will take 2 times 2 squared is 4 milliseconds, right? And this part will take 10 milliseconds, right? And this part will take 25 milliseconds. So the smaller, for a smaller number in value, this part is dominant, but as long as the n is getting larger and larger, right? Think about n equal to 100 or 1000, then which part will be more dominant? Ultimately this part will be more dominant, right? Time consuming, right? Okay, so in case of algorithm analysis, we will consider more for a larger value. We will ignore the any constant value. Okay, which is always 25 millisecond. Okay, and then this part in squared, this part is more dominant than this part. So ultimately we say that big O n squared. We will know big O, what is means O. It is the worst case. Worst case means that in case of very large n. Okay. So this is a way how do we analyze an algorithm. Okay. So let me recap it. So let me start with the statement without any loop. Outside any loop we will take fixed time, constant time, right? Okay, and with a single for loop we will take a single n. If I have two for loops, one inside another, then I will have n squared. Okay, and then now we will consider for large n, we will consider the dominant part. Okay, so these other two parts are nominal over here, ignorable. This is the way how do we analyze an algorithm. Has anyone any question? You understand? Okay. Now let us see another algorithm. If I do have here, let me see what do I have here. Okay. I could not bring my pen. Okay, so here look at my screen. For so 1 to I is or equal to n I plus plus. Do something. Okay. Then I have another for loop. J equal to 0 to j is or equal to n j plus plus. Do something, can be something. For instance, do 2 times 3. Any multiplication or any operation. Okay, do anything, And then for instance I have another for loop k equal to 1 2 k less or equal to n. You see what is 0, then it should be like that. A plus and do maybe task. I can say task 3 it is 1, maybe task 2, and maybe task 1. So task 1, task 2, and task 3. So now if we analyze this kind of algorithm, what will be our time efficiency, time complexity, or you can say. So here for we will say this part. So here I say n big O n, right? And this part again big O n, right? And this part again big O n, right? Then if you add up all the 3 parts, then we will have apparently 3 big O n, right? And then any constant number, if it is inside n, inside the parenthesis or outside parenthesis, no matter, just you say big O n. Oh, sorry, you don't see here, right? So then if you see just you say big O n plus big O n plus another O n. That means this algorithm takes n times, this algorithm takes n times, and this algorithm takes n times. Then totally it will take n times, because compared to n, a very large value, 3 is nominal. Okay. But now, for instance, if I have thousands or 1 million like this kind of for loop, individual for loops, not one inside another. Okay. Now, for instance, if I have this kind of like dot 1,000 times, maybe 1 million times. Okay. How many people in the USA have? Maybe 330 million, right? Whatever. So okay. So I have many, for instance. Big N. So in case, for instance, say that there is a very large group, okay, maybe 330 million big O n. Okay. Now in that case, we will consider which one is dominant. N, whether n or the 330 million. 330 million is a fixed number, right? But n is unknown, right? It can be close to an infinite number, right? Any number. Okay. So our goal is to develop an algorithm that can be used for any kind of operations, similar operations, any kind of data, any number of data. So still in this case we can say that our efficiency is big O n. So here even the 3030 million is a big number compared to n maybe 1 million. Still it is dominant. We will consider this part. Okay. So especially when you understand the algorithm and do analysis, you will look for how many loops are there. Is there any internal and external loop? And that part will be dominant. Okay. Especially we will see this whenever if we analyze sorting algorithms. Then we will see this. Like you are familiar with sorting algorithms, binary sort, right? Bubble sort, merge sort, and in this course you will learn a few more sorting algorithms. There are some sorting algorithms that are specified, designed to do some specific task. We will discuss that, but in our next lecture we will cover this. We will complete next lecture. So let me see. We will come by this in our next lecture. So your task will be, when you go home, please download the book from D2L. Okay, and okay, read through, go through this preface chapter, this content page. Okay, and look at that. Read the only title. What are the, how many chapters are there? You will not remember. You don't need to memorize. Okay, but just have a look and what are the topics in this book have. Okay, just go through like this. Go through like this. Go to the subtitle, major title and the subtitle. Okay, you don't need to memorize. Just look at this. Okay, then if you have another few minutes to go through this book, or if you have more interest, then look at this. Actually, start the chapter 2. Okay, but it's not required. But the required thing is that read the syllabus, please. Or you will get a quiz next week based on the syllabus. Okay, has anyone any questions so far? Okay, thank you so much. Good luck, everybody. Okay, see you day after tomorrow. Thank you.